In this video, I'm going to be examining each one of these beakers to identify whether it meets the requirements for a buffer. So, in this first beaker, we have 1 molar of HClO and 0.65 molar of ClO minus. So, the Ka for HClO is 3 times 10 to the negative 8. So, looking back at our requirements for a buffer, we need a weak acid or base with its conjugate, and the Ka or Kb value needs to be between 10 to the negative 3 and 10 to the negative 12. So, our Ka is 3 times 10 to the negative 8. So, that fits the requirement for a buffer. And we can see that when we remove the hydrogen from HClO, we are left with ClO minus. So we have a weak acid and its conjugate base. So requirement number 1 is met. So requirement number 2 says the ratio of the base over the acid is equal to 0.1 to 10. So our ratio needs to be between the 0.1 and 10 value. So if we take the ratio of our base to acid, this is going to be our base, which is ClO minus 0.65 molar, over our acid concentration, which is 1 molar. 0.65 divided by 1 is 0.65. So requirement number 2 is met. Requirement number 3 says the concentration of acid or base needs to be within the range of 1 times 10 to the negative 3 molar and 1 molar. Both the acid and the conjugate base here both fit that requirement, so we can call this beaker a buffer. Let's look at the second beaker. So we have 0.5 molarity of CH3COOH. This is acetic acid. So the Ka is 1.8 times 10 to the negative 5th. The first requirement says we need the Ka to be within 10 to the negative 3 and 10 to the negative 12. So that would meet that requirement. However, we do not have the conjugate base. So in order for this to be a buffer, we would need a concentration that would also fall into that ratio of CH3COO minus. That would be the conjugate base, because removing that hydrogen right there would give us the conjugate base CH3COO minus. So because we do not have the conjugate base of our weak acid, we cannot call this a buffer. Moving on, we have 0.25 molar of HCl and 0.25 molar of Cl minus. So we can see when we remove that hydrogen, we get Cl minus. So we do have an acid and its conjugate base. However, we need to look at the Ka. The Ka for this acid is 1 times 10 to the positive 6. That is a very large Ka value. HCl is actually a strong acid. And remember, we need a weak acid or base. So because HCl is a strong acid with a Ka that falls out of the range, this is not a buffer. So you need to meet all the requirements to be a buffer. So even though we have a concentration of 0.25, which meets requirement 3, we have a good ratio, we have a 1-to-1 ratio, which falls within that range, we do not have a weak acid or base. So because we failed to meet one of the requirements, this is not a buffer. Looking ahead, we have 1 molar of NH3 and 1 molar of NH4 plus aqueous. So we have a Kb value of 1.8 times 10 to the negative 5th. Remember, we need to be in the range of 1 times 10 to the negative 3 and 10 to the negative 12. So looking at NH3 and NH4 plus, we have a weak base. And when we add a hydrogen, we get the conjugate acid. So we have a weak base and a conjugate acid pair. So this meets requirement 1. Our second requirement, do we have a ratio between 0.1 and 10? Well, 1 molar over 1 molar is 1. So our ratio is 1. So that falls within the range of 0.1 to 10. Then our third requirement, we need to have the concentration of both of them to be between 1 times 10 to the negative 3 and 1 molar. So we can see that there is a 1 molar concentration of each of them. So this is a buffer. Looking ahead, we have 10 molar of HClO and 5 molar of ClO minus. So we saw in the first beaker that HClO was a weak acid, and we have its conjugate base. So that requirement is met. We have a ratio of 5 over 10, which is 0.5, which falls in the range between 0.1 and 10. However, the requirement that both of them must have a concentration between 1 times 10 to the negative 3 molar and 1 molar is not met. 10 molar and 5 molar is much too high to establish a buffer. So because it fails to meet that requirement, this is not a buffer. So we have 0.75 molar of HA. So HA can mean any acid, and we have 0.25 molar of A minus. So the conjugate base of that acid. So we have an acid and its conjugate base. So the Ka is 4 times 10 to the negative 6. So that falls within the range for our Ka. So we have a weak acid and its conjugate base. So what about the ratio? We have 0.25 over 0.75. So this is about 1/3 or 0.333 repeat. So this falls within the ratio of 0.1 to 10 for our base to our acid. So that requirement is met. And the concentration of each needs to be between 1 times 10 to the negative 3 molar and 1 molar, which both of these meet that requirement. So moving on to this beaker, we see that we have 1 molar of OH minus, and the Kb is 0.4. So first of all, there is not a conjugate for OH minus, so this cannot be a buffer. And second of all, the Kb is 0.4, which also indicates that we are not in the range for our Ka or Kb in order to meet the requirements for a buffer. So this beaker is not a buffer. This is hydroxide, and this is a strong base. So looking at our last example, we have 0.5 molar of acetic acid, and we have 0.005 molar of CH3COO minus. So we have the Ka value 1.8 times 10 to the negative 5th. So that tells us that we are within the range, and this is a weak acid. And we can see that we have the conjugate base, because when you remove this hydrogen, you are left over with CH3COO minus. So we have a weak acid and its conjugate base with the Ka value that falls within the range. The ratio of our base to acid is 0.1 to 10. Let's see if that works. So we have 0.005 over 0.5, which will give us 0.01. So the ratio of our base to acid needs to be within 0.1 to 10. So this does not meet that requirement. So this is not a buffer. So this is not a buffer. So going through each one of these examples, we can get some practice on how to identify a buffer. And remember, you need to meet all the requirements in order for it to be a buffer. If one of those requirements is not met, then it is not a buffer.